You might think Earth or the Sun is the oldest thing in the solar system, but the title goes to tiny minerals and meteorites. They're called CAIs, short for calcium aluminum rich inclusions, and they formed about 4.567 billion years ago, when the solar system was just a swirling cloud of gas and dust. These were the first solids to condense from the hot solar nebula, long before planets like Earth even started forming. You can see them in meteorites like Allende, where they appear as pale specks in dark rock, like ancient timestamps frozen in stone. Some meteorites also contain pre-solar grains, stardust from before the solar system. But since they came from other stars, they don't mark our beginning. For the true age of the solar system, CAIs are the clock. Like and subscribe for more space truths, the kind written in stardust. Pluto's icy surface looks red, not from rust, but from chemistry happening in deep space. Sunlight and cosmic rays strike Pluto's frozen methane and nitrogen, breaking apart molecules and recombining the fragments into complex organics called tholins. These reddish-brown compounds slowly coat the surface, especially in dark regions like Cthulhu Macula, and even form hazy layers in the thin atmosphere. Thanks to NASA's New Horizons mission, we now know that even with weak sunlight and a ghost-thin atmosphere, Pluto is still chemically active, proving that space is the ultimate slow cooker for alien worlds. Like and subscribe for more far-out facts from the edge of the solar system. Uranus is tilted about 98 degrees, so it rolls around the sun. That means decades-long seasons, around 42 years of daylight, followed by 42 years of night at the poles. Neptune is so far from the sun that it takes 165 Earth years to orbit once. Since its discovery in 1846, it's only completed one full lap. From Earth, the sun looks yellow because our atmosphere scatters shorter colors. In space, astronauts see its true color, bright white. That's why solar spectra show a full rainbow of wavelengths. Did you know Jupiter might be the reason we're still here? This gas giant is over 300 times the mass of Earth, and its gravity acts like a giant shield. When comets or asteroids fly through the solar system, Jupiter's pull often bends their paths, or even swallows them whole, before they get anywhere near us. Without our giant neighbor acting like a cosmic vacuum cleaner, the history of life on Earth could have been very different. Venus is often called Earth's twin due to their similar size and composition, but it's a hostile and extreme version of our planet. Its surface reaches nearly 900 degrees Fahrenheit, hot enough to melt lead. Interestingly, at higher altitudes, compounds such as lead sulfide and bismuth sulfide may condense and settle out of the atmosphere, forming a reflective metallic frost on mountaintops. These unique weather patterns make Venus one of the most bizarre and inhospitable planets in the solar system. Mercury isn't just the smallest planet, it's also still shrinking. As its massive iron core cools, the planet contracts, buckling the crust into giant cliff-like wrinkles called lobate scarps. Some of these cliffs stretch hundreds of miles and rise more than a mile high. Scientists estimate Mercury's radius has shrunk by over 4 miles in billions of years, and evidence shows the surface is still shifting today. It's proof that even the smallest planet can surprise us with big, ongoing changes. Not every planet has a star. Rogue planets were likely kicked out of their systems and now wander the galaxy in darkness. Some may even keep warm with internal heat. Ever wonder how far and how big each world in our solar system really is? The Sun is colossal, about 1.39 million kilometers, 864,000 miles across, holding nearly all the system's mass. Mercury, just 4,880 kilometers, 3,032 miles wide, sits 57.9 million kilometers, 36 million miles out, and bakes in extreme heat and cold. Venus, Earth's twin at 12,100 kilometers, 7,520 miles, is 108 million kilometers, 67 million miles away, hotter than Mercury thanks to its thick greenhouse atmosphere. Earth is 12,756 kilometers, 7,926 miles across, 149.6 million kilometers, 93 million miles from the Sun. the only planet we know with liquid water and life. Mars, at 6,800 kilometers, 4,225 miles, lies 228 million kilometers, 142 million miles away, and boasts Olympus Mons, the tallest volcano in the solar system. Jupiter, a giant 139,820 kilometers, 86,880 miles wide, is 778 million kilometers, 484 million miles out, home to the Great Red Spot storm bigger than Earth. Saturn, at 120,536 kilometers, 74,900 miles, orbits 1.43 billion kilometers, 890 million miles away, with its stunning icy rings. Uranus, 51,118 kilometers, 31,763 miles across, and 2.87 billion kilometers, 1.78 billion miles away, spins on its side like a rolling ball. Neptune, 49,532 kilometers, 30,775 miles wide, and 4.5 billion kilometers, 2.8 billion miles distant, whips up the fastest winds in the system. And yes, Pluto, just 2,377 kilometers, 1,477 miles wide, orbits a staggering 5.9 billion kilometers, 3.67 billion miles away. Though a dwarf planet, it has mountains of solid ice and a heart-shaped glacier. So tell me, which world in our solar system fascinates you the most? Let me know in the comments. Be sure to like and subscribe if you like this content. The moon is slowly drifting away from Earth, about 3.8 centimeters every year. In the distant future, this will make our days longer as Earth's rotation slows down. Space is silent, except near a black hole. NASA recorded sound waves from a black hole in the Perseus galaxy cluster. By boosting the pitch trillions of times, we can actually hear it. The eerie sound? A deep cosmic hum that scientists call the voice of the universe. On Venus, a single day lasts longer than its entire year. That's because it spins so slowly on its axis, taking 243 Earth days to rotate once, but only 225 Earth days to orbit the sun. So if you lived there, a year would pass before your first sunset. In about 5 billion years, the sun will expand into a red giant. It will grow so large, it will swallow Earth's orbit completely. Our home planet could vanish into fire. That is, if it hasn't been absolutely destroyed by us first. Either way, we're screwed. Saturn's beautiful rings are temporary. They're made of ice and rock, and gravity is slowly pulling them into the planet like a cosmic rainstorm. In about 100 million years, Saturn may look completely bare. If humans are still around, the night sky will be missing one of its greatest sights. You're drifting silently through space, the stars brilliant around you. Ahead, the universe twists and bends in impossible ways. You're approaching one of the strangest, most dangerous objects in existence. A black hole. Light itself can't escape it. Space and time are warped beyond recognition. And you wonder, what would actually happen if you fell in? Could you survive? A black hole isn't really a hole at all. It forms when an enormous amount of matter collapses into a tiny space. Imagine the mass of a giant star squeezed down smaller than a city. The result is gravity so strong that nothing, not even light, can escape once it gets too close. That boundary is called the event horizon, the point of no return. Cross it, and you're trapped forever. As you drift closer, the light around you warps. Distant stars stretch into arcs. The black hole acts like a cosmic funhouse mirror, bending light with its gravity. Time slows compared to the rest of the universe. To outside observers, you'd appear to crawl toward the horizon. But for you, everything feels normal. Then, tidal forces take hold. Gravity pulls harder on your feet than your head, stretching you thin. Scientists call it spaghettification. Not all black holes behave the same. A small, stellar mass black hole would tear you apart almost instantly. Its event horizon is so close to the center that tidal forces there are enormous. But supermassive black holes, millions or billions of times heavier than the sun, are different. Their event horizons are much farther out. Tidal forces at the edge can be weak, so you might cross without feeling a thing. Smooth sailing, at least at first. Crossing the horizon is like stepping off a cliff in the dark. There's no going back. Every path now leads inward, deeper toward the singularity, the central point where, according to relativity, density becomes infinite, and physics as we know it breaks down. Near the singularity, you'd almost certainly be torn apart. But what happens to the information that made up you is one of science's greatest mysteries. Physics says information can't be destroyed, yet from the outside it looks lost forever. Stephen Hawking showed black holes emit faint Hawking radiation, meaning they can eventually evaporate. If they vanish, what happens to the information? Some believe it's encoded on the event horizon. Others think it leaks out with radiation. The answer may require an entirely new theory of quantum gravity. So, could you survive? For a small black hole, no. The forces would kill you instantly. For a supermassive black hole, maybe. At first, you might glide past the horizon unharmed, but the singularity always wins. Black holes don't just swallow matter. They remind us that the universe still holds secrets beyond our reach, and that one day, new physics may finally reveal what really happens inside. If you enjoyed this journey into the unknown, make sure to like this video and subscribe for more content like this. Saturn reaches opposition when Earth passes directly between it and the Sun. During this alignment, Saturn appears brighter and larger in the night sky than at any other time of the year. In 2025, Saturn's opposition will occur on September 21. Around this date, Saturn is visible for most of the night. With a small telescope, observers can clearly see its rings. High-quality binoculars may reveal Saturn's shape, but typically not the rings in detail. Opposition is considered the best time each year to observe outer planets like Saturn. September 23, 2025 is Neptune's big night. On this date, Earth will move directly between the Sun and Neptune, putting the icy blue planet at opposition. That means Neptune is at its closest and brightest of the year, rising in the east at sunset, and visible all night. But here's the catch. You won't see it with the naked eye. At 30 times farther from the Sun than Earth, Neptune is still too faint, so you'll need binoculars or a telescope to spot its tiny blue disk in the constellation Pisces. Don't miss the chance to see our solar system's most distant major planet at its best. Beneath the icy surface of Saturn's moon Enceladus lies a hidden ocean that could rival Earth's. NASA discovered this secret world when they spotted geysers blasting water vapor and ice hundreds of miles into space. These plumes revealed a salty ocean beneath the ice, and even organic molecules, the building blocks of life. Enceladus is only about 313 miles across, but it's become one of the most intriguing places in the solar system. Some scientists even believe it could be the best place to search for alien life. So what do you think? Could Enceladus hold life beneath the ice? Like and subscribe for more space facts. In space, the biggest danger isn't always the big stuff. It's the tiny ones. Micrometeoroids are tiny bits of rock and metal zipping through space at speeds up to 15,000 miles per hour. They may be smaller than a grain of sand, but at those speeds, they hit like bullets. Every spacecraft, from satellites to the International Space Station, has to be shielded against them. In fact, the ISS is wrapped in special layers called Whipple shields that absorb the impact. Without them, even these microscopic projectiles could puncture walls or damage vital systems. Space is full of unseen hazards, proof that sometimes the smallest threats pack the biggest punch. Like and subscribe for more space discoveries. NASA scientists are exploring how to build habitats using the moon's own soil, called regolith. Instead of shipping heavy materials from Earth, they want to 3D print shelters directly on the lunar surface. These structures could shield astronauts from deadly radiation, micrometeoroids, and wild temperature swings that range from boiling hot to freezing cold. Experiments on Earth already show that regolith-based space concrete is strong enough for construction. If successful, these habitats would be the foundation for long-term missions, and even a stepping stone to Mars. Like and subscribe for more space exploration facts. Black holes or wormholes? Which one is more mind-blowing? Black holes are very real. Formed when massive stars collapse, They bend space-time so strongly that not even light can escape. We've even imaged them, M87 in 2019 and Sagittarius A at the center of our galaxy in 2022. Black holes can merge, sending out ripples in space-time called gravitational waves, which LIGO has detected here on Earth. Wormholes, though, are still just math on paper. General relativity allows for them, tunnels linking distant points in space and time. In theory, they could let you cross galaxies in seconds, but there's no evidence they exist, and keeping one open would require exotic matter we've never seen. So, the reality of black holes is terrifying and proven, while the dream of wormholes is pure science fiction, at least for now. Like and subscribe for more epic space discoveries. The sun's magnetic poles are flipping, not physically, but magnetically. About every 11 years, during the peak of the solar cycle, the sun's magnetic field reverses. North becomes south and vice versa. Right now, scientists are observing solar cycle 25, which is approaching its maximum, a time when the sun becomes most active. This surge in magnetic activity produces sunspots, solar flares, and massive bursts of plasma called coronal mass ejections. These solar storms can affect satellites, disrupt communications and power grids, and paint the skies with dazzling auroras. It's a powerful reminder that our seemingly calm sun is a massive, churning magnetic engine at work. Like and subscribe for more space science, because space weather is still the weather. Betelgeuse, the massive red supergiant in Orion, will go supernova. Eventually. But any time in astronomy can mean tomorrow, or 100,000 years from now. It's in the late stages of its life, and models suggest it's nearing the end. But not just yet. After a strange dimming event in 2019-2020, some speculated the star might be close to exploding. However, most recent studies suggest Betelgeuse still has plenty of fuel left, and probably won't collapse in our lifetime. When it does go supernova, it could shine nearly as bright as the full moon for several weeks, even during the day. It's one of the most studied stars in the sky, and its pulsating brightness continues to fuel both scientific research and cosmic curiosity. Like and subscribe for more space updates. We promise not to go supernova in the meantime. Here's a space riddle. Mercury is the closest planet to the Sun, so it must be the hottest, right? Wrong. Venus actually holds the title. Even though it's one planet farther out, Venus is wrapped in a super thick atmosphere of carbon dioxide. That atmosphere traps heat through an extreme greenhouse effect, pushing surface temperatures to about 900 degrees Fahrenheit, hot enough to melt lead. By comparison, Mercury with no thick atmosphere just bakes in direct sunlight and cools quickly at night. So Venus is the true oven of the solar system, proof that atmosphere can matter more than distance from the sun.